Hello everybody, I'm Gökhan Gökçe. I'm working in Çukurova University Fisheries faculty. First of all, I want to thank to Dr. Alessandro Lucetti for giving me this opportunity. Here I'm going to talk about lagoon fisheries and barrier trap selectivity. Here I am going to talk about the geographic positions of Turkey. Turkey is the far end of the Mediterranean Sea. It's like a rectangular shape country. I live in Adana. It's the southeast part of the Mediterranean. This is the very end of the Mediterranean Sea. We have two different bay around my city. One is Mersin Bay, and other one is the Iskender Bay. My city has an important place in the Turkey. According to lagoon fishery, we have 5 different lagoons in my city. One of the lagoon is biggest lagoon in Turkey. These are the Mediterranean region lagoons in 5 different cities of Turkey: Hatay, Adana, Mersin, Antalya. We have 7 lagoons. More than 10,000 hectares surface they have. My city, Adana, has 5 different lagoons and approximately 9,000 hectares surface area. Akyatan Lagoon here is the 5,000 hectares, the biggest lagoon in Turkey. These lagoons, as you can see here in the map, commercially exploited lagoons. We call this kind of lagoons dalyan in Turkish. I think in Italy you are saying these salinas, if I am right. Generally, Turkish lagoons has shallow waters. In Adana, maximum 1.5 meters depth. This is the deepest point of the lagoons. Mostly shallow waters between 40 centimeters and 60 centimeters. They have very high salinity. 45 ppm it's the average, but mostly in the shallow areas, salinity we found more than 75 ppm. Most of them has no freshwater inlet, freshwater sources to the lagoon, but some has, but these are affected by the agricultural waters. These areas has international conventions like Ramsar areas and wildlife development sites. And also this is protected by the absolute protected regulations in Turkey. Lagoons are exploited by the traditional barrier traps. Most of the barrier traps made of wood and cane, as you can see in here in the picture, and some has metal materials, as you can see the top right picture. Most of the fishermen can use fire net, long line, gill net and trap. Fire net used for catch shrimp and eel. Trap is used for blue crab. Long line used for sea bass, and gill net used for mullets and sea bream. According to scientific literature, in the Mediterranean lagoon fishery, scientists found more than 20 different species lived in the lagoon area. These are, some of them has commercial importance, some has not commercial importance. These are the commercially important species and commercially important products from the lagoons. I know you are very familiar with these species and you know very well these species: flathead gray mullet, sea bass, killed mullet. Maybe you don't know this one. This is very special for the Turkish Mediterranean lagoons. Small fatty mullet, sea bream, blue crab, eel, tiger, prawn. It's weird to catch prawn in lagoonal area in Turkey. And also they produce havyar. We call it havyar. I know its Italian name is botarga, from the flat-head gray mullet. Here I want to show you some official statistics from one of the biggest lagoon of my city, Akyatan Lagoon. These productions data belongs to years between 1976 and 2015. There appears to be rapid decline in some fish species. This shows that there is need to develop more efficient management mechanisms for sustainability of the lagoon fisheries, such as promoting more selective fishing gears, sending broad stocks to the sea, and not hunting the juveniles. This graph belongs to the same lagoon for the same years. At the beginning of the graphs you can see more than 300 tons of fish captured in this lagoon. But today almost half of it can captured by the fishermen. Turkey has a special regulations for the lagoon fishery. Here you can see the regulations changes by the year. At the end we have certain bar distance for the barrier traps for all lagoons in Turkey, which is 3 centimeters. I'd like to show you a short film to show you how the traditional lagoon fishery is done in Turkey, and you will watch a journey through the eyes of the catch. This video was prepared by me as an amateur. Please excuse for the quick transitions. Lagoon fisherman is going to collect fishes in the dead chamber with his fish scope. Fishermen use a waterway made of plastic pipe to facilitate the transportation of fish. This is the image from the dead chamber. The catch put in the water pipeline. You can see the black pipe behind all the fishermen. All the catch put in that mount in the pipeline. They use this waterway to transport all fish to the land. The waterway is then connected to the conveyor belt and the fish are boxed for species and size selection. Small individuals return to the sea. This is the catch from the hike season. Eels, mullets, sea bass. This part of this presentation I'm going to talk about the lagoon barrier trap selectivity. We did a experimental test for the barrier traps to improve selectivity for sustainability lagoon fishery and also try to determine size selectivity of different bar distance for different target species. We use 5 different commercial species which has different morphology. This is very important for the lagoon barrier traps. All the fish has different morphology. Some has large head, some has laterally compressed. We followed a simulation-based selectivity methodology the called fish select method produced by the Bent Herman from Denmark. This is very complicated methodology. Just I want to say that we create a simulation for the selectivity and we simulate the bar distance and we use computer science to get the results for the selectivity. The fish morphology is very important for this methodology, and so we use bar templates and we test from 5 mm to 50 mm bar distance for the trap selectivity. And we get these results for 5 different species. Here you can see the Turkish and the English name of the species. From 5 mm to the 50 mm. The x-axis says the bar distance in millimeter and the y-axis is the total length in centimeters. And the color codes for the different species you can see here. We need to find one distance for all species or suitable bar distance for each species. So each species has different minimum landing size, so it is very important to determine the different selectivity results for each species. This is the selectivity results for minimum landing size. We test 5 different species. You can see here 4 different species because killed mullet has no minimum landing size, so we omit it in this graph. There is a color code here which describes different species, and there is a numbers in front of the colors. The upper part is the minimum landing size, lower is the bar distance calculated from our simulation results of the selectivity. The orange one is for sea bream. The minimum landing size of sea bream is 20 centimeters. We can briefly say that if we use 22 millimeter bar distance for this species, we can catch half of the 20 centimeters of sea bream in the trap, and you can see the other ones. I don't want to read all of them or talk about all of them. Just I want to say that this is very complicated situations. These results from the simulations based. So we need to retest this in the real life. These are the species based, but in the real life it's very complicated situation. More than one species caught in the dead chamber. So it's important to see the behavior of the fish. So then we need to retest it in the real life to get the perfect to get the perfect results for the selectivity. I want to thank you in advance for listening me. Grazie mille per avermi ascoltato. See you maybe next time in somewhere. Thank you very much.